What we've been talking about so far has been really heavily focused on the interaction between our environment and what we learn by interacting with our environment. We've looked at behaviorists and radical behaviorists, and you might have noticed that we've been pretty severely lacking on what's going on internally. So we're going to take a brief dip into cognitive psychology and specifically social learning, and that's how we're going to wrap up the chapter. So for cognitive psychology, Tolman is one of our big names here. And so Tolman said that our explanations for behavior should include more than just environmental stimuli, and it should also include more than just publicly observable behavior. So he was fed up with all of this classical and operant conditioning where you were looking at something observable in your environment and something observable that you do in response to it. He wanted to look at things that were going on internally. What about what's going on in your head? What about your thoughts? What else is happening? What else can we look at? And this is what pushed that advancement of cognitive psychology. And so specifically, we're going to be talking about a concept called latent learning. And this is when you learn a behavior, but you don't actually demonstrate that you've learned that behavior until the opportunity presents itself. So until you are motivated or reinforced for performing that behavior, we have no way of really telling if you've learned anything. And this was tested mostly in terms of what's called cognitive maps. So our mental representations in our minds of our environment. So the idea here is that if we're interacting with an environment, we might not be able to see any change in behavior because we're just wandering the environment. But we would be building up a map, a representation of that environment. And then if later it mattered what we knew about that environment, we could then see changes in behavior after the fact. So an example that helps illustrate what I'm talking about is Tolman's looking at T mazes, or specifically strings of T's intersecting in rats. So if you've ever worked with rats or heard of people working with rats, especially with navigation, they love their mazes, and they call them mazes despite the fact that most of them are fairly simplistic. So they have a T maze, which is what it sounds like. It looks like a capital letter T, where a rat runs down a hallway and then is faced with the choice to turn left or right, and one or the other would be correct. We also have plus mazes, which would be what you'd expect, a big plus. You can also have radial mazes, which is sort of like multiple arms. So it's kind of deceiving to have them called mazes. But this one here is a series of those T intersections all stacked together. So this one's closer to a maze than most rat navigation research would be. And so if we look here, there's a starting point and an end point. And so there is sort of a right and wrong way to turn if you were trying to get from the start to the end. But if you have a rat who's presented with the opportunity to wander around in tunnels, in mazes, and there's nothing for them at the end, there's no motivation for them to find that end. So Tolman would allow rats to hang out in the maze, to wander around. They like tunnels, so they don't need to leave. There's no motivation to go anywhere, so they would just experience the maze. And if they were learning anything about it, if they were forming a cognitive map, then we would see changes in their behavior later when there was an opportunity or when there was motivation to see that improvement. So the idea here is that there were some rats who had experience with this maze and knew what was going on, and then there was a control group who hadn't seen the maze before. And so if we have the group that theoretically has formed a mental map, and now we introduce some kind of reinforcer, some kind of motivation. What if we put food at the end? Well, then the rats would have reason to get out of the maze more quickly. So if we place food at the end and then look at how quickly the rats that have a theoretically mental map of the maze, they should get out faster than the rats who have no experience with the maze, which is what they find in pretty much all of their different iterations of this. So that's evidence for A, cognitive maps, because they had learned something while wandering around in the map, because they would turn the right way more often than the wrong way to get out. But we also see evidence here for latent learning because they didn't show any difference in their behavior at the start, but once they were motivated to get out, then they showed that improved speed. They learned and changed their behavior to escape more quickly when there was reason to. So this gives us evidence for both of those concepts. So next we're going to get into social learning proper, or sometimes called observational learning. And our big name here is Albert Bandura. And so Bandura focused on studying kindergarten students, trying to establish observational learning as a concept. And this kind of makes sense. We can think of examples of classical conditioning and operant conditioning in our own lives. We behave in particular ways because of associations that we've made, or maybe we do certain behaviors because our parents encouraged it, and we avoid other behaviors because those were discouraged. So we can see those pretty clearly, but a lot of our learning actually comes from watching our environment. So with social learning, we start understanding what we should be doing by watching others. And a great example of this that I experienced was coming back to campus for the first time after we were online for a little bit. I had no idea what the new setup was, and I wasn't sure what to do. So I sat in my car for a little while and I watched where other students were going. Where was the line forming? What did people have out when they got to the door? So I watched other people get into the building, and then I copied their behavior so that I could get into the building too. So I exhibited social learning or observational learning by watching somebody else achieve their goal, and then I copied it to achieve the same goal. And we could even call this vicarious conditioning. So if we're looking or watching someone go through a conditioning process, whether it's classical or operant conditioning, usually operant conditioning, we can learn vicariously through them. So if we think of two rats, we have a model rat that's in an operant box, and they're pressing a lever to get food. If we have an observer rat who's just watching the other rat, they might start to make an association between pressing that lever and getting access to food. Though our observer isn't actually experiencing it themselves, they might make some connections based on what they've seen someone else do. And so we can actually break this process down into 4 distinct phases. And this is where we start seeing some weird terminology again. So I'll use a couple of options here. But phase 1 is attention. So our learner is our observer, the one who's watching. And our model is the one who's called a trainer sometimes. I prefer model because they're modeling the behavior. But if we think of them as showing that behavior to our observer, trainer kind of makes sense. But our attention stage is basically saying, is our observer paying attention to the model rat? Are they watching what the other rat is doing? Retention, our second stage, asks, is that observer thinking about or sort of making some connections in regards to the behavior that our model rat was expressing? So when that model rat pressed the lever and got food, our observer should be watching, paying attention, and forming some kind of connection, retaining some of that information to act on later. Our next stage is production. So this is when our observer gets the opportunity to produce that response themselves. So we move our observer into their own operant box. We give them a lever and the opportunity to press that lever. And then we also have a stage of motivation where when they press that lever, they should be reinforced with food just like the model rat was. So we would make it more likely for them to continue doing that behavior in the future. So this process could actually help us, say, skip things like shaping because they're learning to make these connections, to do this behavior by watching someone else do it. And there's lots of really cool research on this topic. One of the ones I've been reading lately comes from the U of A, where they were looking at observers and modeled behavior in nest building with zebra finches. So they had model zebra finches build nests, and the observers would choose to copy their choice in nest material based on a bunch of different factors. And we can look at what makes them more likely or less likely to copy. So there's lots of really cool research in that area nowadays. So some interesting stuff going on. But that's just sort of the basics of our observational learning. And then if we wanted some sort of concrete evidence beyond some of our behavioral studies, we can actually look at some neurological indicators for this kind of observational learning. And these are mirror neurons. So they're neurons that are activated by both performing an action and watching someone else perform that action. So it's kind of like there's a part of our brain that responds to us doing a particular behavior, but also to seeing someone else perform that behavior. So we can link or kind of imagine us doing that behavior while watching them do it. So we typically see this in sort of simpler systems. There's a lot of research on these in, say, rats and even primates, but there's less work in humans, probably just because our brains are a lot more complex and our activities are a lot more complex, but there's a lot of really cool research there as well. And of course, we can't talk about observational learning without talking about one of those core pillars of weird psychology experiments from the past. So maybe you've heard of the Bobo doll studies, or maybe you are just being exposed to this nightmare fuel for the first time. But this was a very famous experiment looking at aggression and specifically learning aggressive behaviors in children. So the setup here is that they had these Bobo dolls. You might have also seen them called like Weebles. They're really heavy at the bottom, and so when they sort of tip back and forth, they don't fall over. They will right themselves because of that low center of gravity, but it allows you to sort of interact with them and push them pretty aggressively, but they'll always stand back up again. So they used these Bobo dolls that were sort of impossible to tip over and terrifyingly painted to look like clowns. And they were having sort of a model, which would be an adult, interacting with the doll. And they'd have observers, so children, who would watch the adults interact with the doll. And of course, we care about aggression. So we were looking at what happens if an adult walked in and acted aggressively towards this doll, especially if they were aggressive and they were encouraged for their aggressiveness. So if an adult walked in and punched the doll and somebody else laughed or said, "Do it again," the children would then be very likely themselves to copy that behavior when given the chance to interact with the doll. And if you look closer at some of these images, these kids went nuts at these dolls. There's a lot of videos of this. So if you wanted to take a few minutes on YouTube, they have a lot of sort of commentaries on these kinds of studies, and they're very entertaining. But they also found that it worked the other way, where if an adult was aggressive towards the doll and was then scolded, the children were then less likely to be aggressive themselves. So lots of evidence there that children watch adults and also learn from the consequences of the adult's actions when deciding how to behave themselves. All right, so we have 2 slides left. The first is going to be just a brief reminder of this concept of biological preparedness. So we talked about this first in our classical conditioning, and we mentioned that it's easier to form associations between certain types of stimuli and certain types, or I guess between certain types of stimuli, period. There's also sort of a biological preparedness to form associations between certain types of stimuli and certain outcomes. So it isn't just classical conditioning that preparedness can be set up for. It also works with operant conditioning. And also we can have things where we are set up to learn like social behaviors as well. So biological preparedness isn't a classical conditioning alone kind of learning. But we basically have this idea that some events are better signals or better conditional stimuli or better whatever than others based on evolutionary traits. So we have predispositions, sort of innate pathways that make some things easier to learn about than others. And one of the fun examples of this that we can run into, where actually biological preparedness causes problems, was trying to condition raccoons, operant conditioning, there we go, keep the words separate. Operant condition raccoons to put money in a piggy bank for a commercial. So someone was trying to film a car commercial. They wanted a raccoon to take a coin, put it in a piggy bank. And what they were doing through the process of shaping was getting them to sort of pick up the coins, put the coin in the piggy bank, and then pick up another coin and put it in the piggy bank too. And they were being reinforced with food. But the problem here is that food has these biological predispositions. We have certain behaviors that are already associated with food. And if you've ever watched raccoons with food, one of their behaviors associated with food is to sort of rub their hands together with it. So you might see where this is going, but the raccoons were okay with one coin, more or less, but as soon as they introduced a second coin, the raccoon took one in each hand and rubbed them together and refused to let go of them. So we run into this issue where as soon as that particular action is associated with food, it activates other pathways associated with food and can lead to problems. So they never did condition the raccoon to drop the money in the piggy bank because they couldn't get past that. And then the action of rubbing it together itself became reinforcing and they just had to find another way. But there's lots and lots of examples of stuff that we sort of are predisposed to learn depending on our situations. And then our last topic here is to discuss very briefly the idea of learned helplessness. So this ties back to what we had talked about earlier with escape and avoidance conditioning. And so learned helplessness is kind of like when we have an escape conditioning setup, but we're not actually able to escape. So if you experience an aversive situation that you don't get any control over, something that you can't escape or something that you can't avoid, it can actually prevent you from learning anything about escaping or avoiding that situation in the future. So if we think of those shuttle boxes I was talking about before, a normal escape response would be if there's a really loud sound on one side, you would go to the other side of the chamber where it's quieter, you go into the other half. In a learned helplessness setup, they would put a clear wall between them, so you couldn't escape. And eventually, all sorts of different kinds of organisms learn that I have no way of escaping, so I'm not even going to bother. Then if you remove the barrier, those animals still stay in the place with the aversive stimulus because they've learned that it's not worth trying. And so even when presented with new situations, new information, they stay put. And so a lot of the learned helplessness research nowadays starts making connections to things like depression, where if we're in a situation where we've learned that nothing we do helps, we might stop trying to overcome that situation. So even if we get new resources, we might stay stuck. So a lot of the new research in learned helplessness is looking for ways to sort of disrupt that system. How can we introduce that desire to learn to escape these situations even after we've set this up? And so a lot of cases, it would be something like forcing them to move to the other side so that they realize that it's better on the other side, whether you physically move them or set it up in some way that can help overcome this. But there's a lot of really neat research in that area as well.